Hey, g'day, it's Prezzo here, and I'm starting a new project today. And guess what? It's a clock. Now, if you've watched my channel before, you'll know that I'm a bit of a sucker for clocks. But this one, a little bit different, and I'm calling it a Vixie. That's right, a Vixie. So forget your Nixie clocks and your Lixie clocks. The Vixie is the clock for 2020. Now, what makes it different? Because you're probably looking at this and saying, hang on, this just looked like a 7-segment display clock, and I've seen like infinity of those on YouTube. And yeah, you're right. But what makes this one different is that we're going to be backlighting a piece of veneer. Now this is veneer, I think it's aspen. It's about 0.5 millimeter thick, and if we put a strong light source behind that, it becomes sort of semi-translucent. So the clock itself is based on a ESP8266 Wi-Fi microcontroller, which is this one, and we're going to be using RGB programmable LEDs. So these are WS2812B LEDs, and I should also, full disclosure here, this is not my idea. I saw a video on YouTube by a gentleman named Leon Vandenbuckel, and he made what he called a plywood clock. And when I had a look at it, I thought, gee, I can do that. And the difference is that he used a CNC router to make most of the parts for the clock. I don't have one of those, but I do have a laser cutter, and I've sort of substituted that tool to make the clock. Now, I've also been collaborating with Mitch Markin, and he's a bit of a coding guru, and he took the original code that was written by Leon, and he's made a number of upgrades and improvements to that. And you can get the code too. There's a link in the description below if you want to have a go at doing this. Now, the other thing is that I substituted this particular part. Now, this is a laser cut 3mm black acrylic panel that the LEDs mount onto. In Leon's original clock, he used these 3D printed parts. Now, there's also a link in the description below which will allow you to go to Leon's GitHub site, and you can download the STL files to make both these 3D printed parts. And you can use this part as a substitute for one that I've got, but if you've got a laser cutter, you can use that one too. So what we're going to do is we're going to look at the first part today, which is going to be to make the LED displays, and we'll put it together with the Wi-Fi microcontroller, and we'll demonstrate that working. But I'll warn you now, this could be like a 3 or 4 part series. Anyway, let's get busy. Let's start making one of these displays. The LEDs we're using here are WS2812 RGB programmable LEDs. And these come in a sort of a matrix when you buy them like that, and you can snap off individual LEDs and they get bonded into this acrylic panel. So I've got enough of these to do one full clock, and I've ordered some more. So I'm going to do a second clock for my friend Mitch, and we're going to look at a different packaging for the second clock. So basically you just break off as many as you need to do the displays that you have. And we're going to bond these into the acrylic with super glue or a cyanoacrylate adhesive. These LED panels are made from 3mm thick black acrylic. It's been laser cut and laser etched, and there are 2 very small pockets, one either side of the square window, that the LED face will shine through. And the purpose of those pockets is to allow these 2 surface mounted devices. Now, well, let's bring this up and have a closer look. So you can see here there are 2 surface mounted devices, and they stick up far enough to interfere with the fit between this back panel and the LED itself. So each of those little pockets there is about 1 millimeter deep, and when we place the LED in there, it sort of registers with that pocket. And then you can hold that down and bond that into the frame with some cyanoacrylate or super glue. This piece of plastic here is a piece of polyethylene, and polyethylene is one of those plastics that's difficult to bond. There's a group of materials called difficult to bond materials, and their polymer structure is such that the super glue you can't get a grip on it anywhere. So if I accidentally spilled some super glue, it won't stick the whole thing down to the surface here. So the way these works is we just turn them and make sure that the arrows are facing around the entire perimeter of the 7-segment display, and then the last two go across from this point to there. Now that's important when you wire it up, and it means that we can wire our positives and negatives and our data line in straight lines right around the edge of that 7-segment display. So the positive pads are on the outside, negative on the inside, and the data pads are in the center. So what I find is you should just hold that down and then run your super glue around that edge. And you just sort of want to drop. And if you do it properly, you'll see that super glue wick around the edge of the LED. Now it takes a little while to dry, so if you've got to avoid bumping anything as you do this process. Now, if you're working with the 3D printed files that Leon provides on his GitHub site, you do this process exactly the same way. And all I did was I took the STL files that Leon provided and I put those in a Fusion 360. I turned them into a solid part, or a B-rep. I took the B-rep, I made a 2D drawing from it, and I saved that 2D drawing as a DXF file, and my laser cutter will read that DXF file to cut out these profiles. So these LEDs, you can get these on eBay. They're not very expensive. I bought 100 for about 10 Australian dollars. Maybe a bit more with shipping. I'll put the links in the description below if you're interested. And I reckon this project's a good one. Like, although, you know, I've got a laser cutter, you don't need a laser cutter to make this clock. We can talk about that as we go along. Most people these days who are into tech have a 3D printer, and as I say, that, you know, that's a solution that will work for this clock. I mean, if you really want to be super cool with this, you'd have these made as printed circuit boards, and there are some very cheap services out there for doing that now, and you can end up with really professional looking results. But this works. Okay, so that's done, and here's one of the displays already done, and there are 3 wires going in: red positive, black negative, and the yellow is the data line. And you can see that I just simply connected all of the positives and negatives with a single loop of wire. Starts here, goes right around the perimeter, and finishes up over here. So data in comes out through that pad, goes in through that one, out through that one, and so on. So you cannot bridge across the data in and out, otherwise it's not going to work. So there's one, and if I turn that over, you can see the LED showing through the square mask there. Now in practice, we need to add some space between the back of this display and the front side of the wooden face of the clock, and that's done with this 3D print. So that gives you the correct amount of room, and that makes it look like this is a solid segment when it's seen from the front of the clock. I'll show you how that works later. Here's one with the light mask already glued to it, and it's just, once again, you can use cyanoacrylate or hot glue or epoxy glue. This is a 4-digit clock, but Leon actually had provision for a colon between the hours and the minutes on the display, and that's done using 2 3D prints. There's a sort of a tube which also acts as sort of a spacer or a light guide, and there's this little part here which fits over the LED itself, and I'm going to bond that together with super glue. I haven't done one of these yet, so I'm sort of just going to put a drop of glue around that edge there. Yep. Ah, that didn't work. Actually, I'm going to sacrifice that one. That's not terribly neat, but I think it'll work. Alright, so there's our two colon LEDs. We'll just let those set and we can get them wired in. Now they actually have to get wired in between the minutes and the hours. So everything sort of runs in series, and if you leave these two out, the hour digit's going to look stupid. So we'll get them wired in shortly. One of the good things about these acrylic panels is they're rigid enough that you can put this whole assembly in a vise, keep it all steady while you're trying to do all this fine soldering. So we're going to put the positive wire on the positive pad there. Yellow is for the data. Black's our negative, of course. This is where you need to have steady hands, boys and girls, which I don't have. Right, so these three wires just connect each digit panel to its mate alongside, or to the colons, depending on where you're wiring this up. Now I'll also put these on first so I can test the LEDs as I put them in. The very first panel I did, I wired up the whole thing and then tried it, and then realized that somewhere I had a bad connection, and I traced it to about this LED here, but to get it out then it meant removing all of the wires back to that point and then somehow poking it out of the LED frame and then replacing that one LED. So what I'm doing now is I do 2 or 3, test it. If I find there's a fault, it allows me to correct it without undoing everything. So I'll show you how we do that in a minute. Now the wire that I'm using to connect this with is just plain copper wire. Alright, this is just the earth strands from a normal 240 volt flexible cable, and strip the insulation off, and that way it's relatively unoxidized when you go to use it, and it's thin enough to be able to bend it and make it conform to those pads. Now, you don't have to solder it to every single pad on each LED. So for the positive, for example, it's just either one or the other of those pads on the back of the LED there. I find sometimes, especially when you're going around the corners, it's a good idea to actually solder it to the pad closest to the corner, this one here. Otherwise it sort of takes a bit of a shortcut going across the corner. So just get that to conform as best you can and solder it down to the nearest pad. So for example, when I get to this corner here, if I just sort of bend that now, it sort of takes a shortcut. But if I solder it to this pad here, right on the very corner, it keeps it to conform correctly. Now I'm going to tape that around that corner. Now that's as far as I'll go. I'll do those 1, 2, 3, 4, maybe 5 for example, and then check those out and make sure they all work before we go any further. This is where my little dental probe comes in handy. You can sort of hold some pressure down on that wire there. If you solder this one for too long, the one where we started will melt and you're sort of back to square one. Alright, so there's our power wires done up now, and we'll do the little data connections between each LED, and we'll check a few LEDs and make sure they're working. Alright, so that's our first two LEDs done, and what I've been doing with these data connections is I tin enough of the wire so I can just sort of heat it at both ends, otherwise it gets a bit fiddly trying to manipulate the solder wire into place there without this sort of getting loose and falling off again. So we're going to check those first two LEDs and make sure they're working. Well, I know this looks a bit of a mess, but I've got one of my Node MCU microcontrollers set up on a breadboard here, and I've sort of just cobbled everything together, and it's running a sketch called Cylon. That's C-Y-L-O-N, and it's part of the fast LED library, and it just runs a cycle through whatever number of LEDs you've got connected and allows you to test them. So I could use the clock code, but depending on what digits are lit up, you wouldn't necessarily be able to test all of the LEDs on one 7-segment display. So this one allows you to just cycle everything and you can check them. So what I do is every now and then I'll just sort of hook this up, run the code, and if I get an error, just say with this LED here, and I've already put this one in, I can go back and remove that one without too much trouble. Okay, I've got a few more hooked up here now, and I find that as I go along I get a lot more confident, my technique improves. I had a failure on the first one, but since then it's all been good. But it's still worth checking. Okay, alarm one checks out, so that's ready to hook up to the rest of the clock now. I'll peel the paper off this black acrylic later. Let's just keep it clean while we're messing around on the bench. One of the keys to making this clock work is to have a panel. This is the front panel of the clock, and the idea is to have a thickness of wood on the front of that panel which is so thin that the light from the LEDs for each of these segments will shine straight through that wood. So the effect that you get when the finished clock is done is that you've got a plain piece of wood, and somehow magically these 7-segment displays show up on the other side of the wood. Now in the clock that Leon did, he had used a CNC router to cut out a pocket, and the pocket was almost cut all the way through, and it left behind just this very thin layer of wood on the outside. Now I don't have a CNC router, but I have got a laser cutter, so I've used the geometry from this STL file to turn it into a DXF file, and that allows me to cut out each of the 7 segments in each display. And later on I'm going to put a thin sheet of very light coloured veneer on the other side of this, this front panel. Now before I said you don't need to have a lot of expensive tools to make this work. Now you could cut out the very outline of that shape there with a coping saw or a fret saw or even a really sharp knife if you were determined, and the veneer is sort of readily available on eBay, and you can then bond the veneer to the piece of panel that we've got here. So you don't need to have expensive tools to make this work, you just adapt the method to suit what you've got. What I'm going to do now though is I'll use the same piece. This is not the finished one for the clock, by the way. I'm going to use it to join together the 2 colon LEDs. Right, these 3 wires here once again are our positive, negative and our data line, and the colons need to be hooked up in between the minutes and the hours. So there's a sequence of connection that you need to follow to make sure everything lights up as it should. If you check Leon's GitHub site, it shows you a diagram. Also on his video, his YouTube video, shows you the way in which we hook all these up. But what I'll do now is I'll get all of the digits assembled and wired together, and we can test the whole clock. Okay, I know this looks like a bit of a dog's breakfast, but I've wired all of the digits in now and the colons, and we're going to hook this up now to power and see what we get. So power's going on now, and connecting. Come on baby, come on, I know you can do it. Hey! Ah, crikey, okay, all good. Now, what's the time? According to my watch, it is 12:37. So we've got a 7 in this digit here. We've got a 3 in this one here. Our colons are working, but we've got a 3 there. Now, I know this has got some bugs. Now, Mitch Markin is the gentleman that's been helping with the code on this, and he just sent me a new code, and he said that there was an error. This was permanently set in daylight saving time. Now, here in sunny Queensland, we don't have daylight saving time. The rest of Australia has it, but Queensland proudly stands apart. It was tried back in the 70s and it got voted down. We've never gone there since. So that's got to change to a 2. But there's also an error. This should be showing a 1, but Mitch said there was a bug in the code that stopped this digit from flipping over and showing the correct digit there. Apparently it shows the AM times okay. So I'm going to go upstairs and flash the microcontroller with the new code, and we'll try that again. Let's just try the colors though. This little push button's going on the back of the clock. So we've got green, we got yellow, we've got purple, we've got white, blue, red, cyan, green, yellow, purple. Alright, so you can flip through the colors there. And interestingly, some of these colors work really well behind the veneer and others are almost invisible, but we'll get to that later. Okay, let me go and fix the code and we'll come back. And we're back, and the time on my watch, I don't know if you can see that, but it's about 4 minutes past 3, and now we've got 304 on our digits. Remember, we're in 12-hour mode, so the lead digit here for the hours is blanked out. Now, Mitch has put in some extra functionality in the code, and it required putting in 2 extra push buttons. So let's see, this one should give us 24-hour mode. So now it's 15:05, back to 12-hour mode. So now we're 3:05. This one is still the colors, and this extra switch over here is now going to give us daylight saving time. So 3:05. Now we're on daylight saving time, 4:05. So that is all functional now, and what we can do is now try and get some sort of order out of all this chaos and put this into some sort of a package. Man, I love those colors. Oh, that's so fun. Now that we know that all these LED panels are working correctly, we can bond the light mask and the spacer onto the front. So our little spacer frame is going to get held down to the face of that acrylic, and although there are some holes in the 3D print and the laser cutter put the holes in there as well, in practice it's a little bit awkward. There's not a lot of room on the back here to get a screw head in there, so I think I'm just going to hold that and run a bead of super glue around. It'll wick in and hold that together. In reality, the super glue that I'm using is not the really quick setting type, so I'm probably going to have to weight that down with something and do the 2 ends separately. So, put glue around the 2 ends and get that held down somehow. Okay, let's let that bond, and then I can sort of run a bit more super glue around those sort of gapped edges there, and it'll wick in, and that should bond really tightly. As you can see here, I've got the displays now just temporarily mounted to a piece of wood. I've just hot glued them down just so I can show you the effect that we're going to get when this is all mounted in the clock body. I've also updated the latest code to the microcontroller. This is one that Mitch Markin has been working on for me. The original code that I got from Leon didn't work, and Mitch has made a number of improvements, and I'll show you what they are now. Now, when I plug in the power, the first thing you'll notice is the version number of the software. Then you'll see it searching for the Wi-Fi and then connecting. So there's our version number. Now it's searching for the Wi-Fi. It'll go green. There it is. That's connected, and now we're actually displaying daylight saving time. Let's go back to actual time here in sunny Queensland, and it says 9:51, and on my system clock on the computer it also says 9:51. So with the buttons, we've got daylight saving time, we've got another button that'll do 12, 24 hour, and then we can cycle through the colours. So what does that look like when we put our piece of veneer in front of the light masks? Well, that is the effect that you're going to get. Well, I'll just go to daylight saving time. So I reckon that looks really cool. So we just got the blank piece of veneer, that's what it's going to look like, but it's going to be lit from the back with our LEDs. So let's cycle through some colours. There we go. Now you'll notice that this one is quite dim, and for some reason the veneer blocks a lot of that blue light. It's actually quite bright if we take that off. And I thought to myself, you know what, that'd make a really good sort of night mode. So if you had this in a room and you had the lights out, you really wouldn't want this to be too bright. So I figured that there should be some way of fitting a light dependent resistor to sense the room lighting and then have this automatically dim when the room lights go out and then come back to the previously stored colour. So let's have a look. Let's go back. So there's one of the brighter colours, and you have to imagine that in a dark room it's going to be quite obtrusive. So I did a bit of research and I got a light dependent resistor and I've installed that as a sensor. So there it is there, and I figured that I could write the code that would make this automatically go to one of those darker colours. So let's just cover that up, and it goes to that dark blue. The only trouble is when you take the sensor and expose it to room light again, it doesn't change back. So that's about the extent of my knowledge, folks. I can make the sensor do one thing, but I can't get it to reverse that mode. But I've thrown this back to Mitch, and I'm sure that he'll work his magic and get that working for me. So that's where we're headed. Now, I'm going to finish this up here because we're up against our half-hour limit, and in the next episode we're going to do the woodworking, so build the case that goes with this. Oh, I just remembered too, Mitch has also had this blink, the onboard LED, every second, just to let you know that the clock is actually working, so that even if your display is faulty, you can tell that the software is running. So where was I? Okay, so we're going to do the woodwork for the case in the next episode, and we'll try and get a fully functioning clock out of that. And the look that I'm aiming for is a sort of a semi-retro designed console clock. Anyway, thanks for viewing. Thanks to the viewers that have joined me this year. I think I'm up to around about 6,300 subscribers now, which was way more than I ever expected to get. And as we head into the new year, I wish you all the best. Drive carefully, don't drink and drive, stay away from drugs, and I'll see you on the next video.